Hi, my name is Griffin Price, and this is Lab 4 Oscillations. The purpose of this lab is to observe and measure the motion of a mass swinging in an arc while oscillating on a string. The motion is analyzed using tracker, while a computational model is used to predict the same object's motion and plot its changes in energy. The goal is to determine if the model system satisfies the energy principle, and there's a preview of my results in the bottom right there. And now to introduce this lab, let's go over some fundamental principles. The first being Newton's second law, where net force is equal to dP over dt. Net force in this instance is equal to spring force plus gravitational force, which can be rewritten as Ks plus mg. Another principle of this is the energy principle, which is where the change of energy of the system is equal to the work done by the surroundings plus Q, the system being mass, spring, and the Earth, which means that the change in kinetic energy and the change in the spring potential energy and the change of the gravitational potential energy should all equal zero. As you can see, the images on the top there kind of represent what this lab is doing, how the forces are acting, and some other formulas of note are the velocity update formula, the position update formula, gravitational constant, kinetic energy, spring force, potential spring energy, and potential gravitational energy. The observed model, we use tracker to find some data. We're given mass, we're given the initial position from the data of tracking, we're given the length, and we're given that the initial velocity is zero because there's no velocity when it starts still, so the initial velocity is zero, and there's our results in the bottom left right there. Calculating K and L naught, we can use the period of oscillation formula, which is 2 pi root m over K, to find K and LO using what we're given. We rearrange the formula for K, and we find that K in this instance is 6.83 Newton meters. And we can use that K to find L naught, which we use Ks equals mg to find K, or to find L naught, and L naught is 0.123 meters. Now for the coding inputs and equations, all I did was basically put in the information I know. The coding's purpose is to compare our data from tracker and the data it computes, kind of like the perfect data it computes given our initials and given our Ks and lengths and so on and so forth. So that's what I put in, and it also computes all the energies working on this model, which I thought was really cool. So I plugged in the equations for the energies, as you can see, K, Ug, Us, E, in the to calculate how the energies are playing while this system is oscillating and moving. And what we find is that I'm pretty dang close. As you can see, the models are outputs to the right there. Not too bad. Some error for the first model, which is x position versus time, is that the K value we calculated was using Y position data, not X, so there might be some discrepancy there. And for the Y position versus time, a potential error may be that we assume that the system was fully closed, which we know that it is not, when things such as air resistance and other acts can act upon the system, which could cause some discrepancy there. So what does it mean? Was the energy principle satisfied? Yes, it was. The energy must be equal to the work done by the surroundings, which in this case is zero, so total change in energy is zero, and we can see that graphically because the orange line is constantly zero, and what this means is that the kinetic energy of our system keeps canceling out with the potential energies of our system to get zero as total energy. And for the second part of what does it mean, we calculate the two different oscillation periods, the y direction being the one we calculated earlier, and the x direction being a new one using the x direction time oscillation. And what this means is that if we use the x direction for our data, computationally it would work the same, but it would almost mess up everything, because K helps us find spring force, which helps us find potential spring energy, which helps us find total energy, which kind of would give us a whole different graph for if we use this K rather than y direction K. So it kind of messes up everything. It would work